So in the last class, we have discussed about SCD. Okay, where we implement this SCD, as highlighted before, we implement this SCD in the silver layer. We implement this SCD in the silver layer. Okay. Uh, Okay, so every day what we do, we truncate and load the data in the bronze layer. So in the bronze layer, we will have the current date data or current month data. So where we store the historical data, I'll store the historical data in silver layer. So now if I want to generate the report, so I need a complete historical data. That means I cannot delete or update the historical data. So what if client told to delete or update the data? See, if you are doing some deletions, right? So then what you do, you will take some backup, okay, for the deletions. When it comes to updations, so we have SCD types. Okay, remember that when it comes to updations, we have these SCD types. Okay, so what are the SCD types we have? When our client told you to do some operation, okay, so if the same record exists in the table, then what I need to do? Okay, so if client told you this name is SCD type 0 column, which means I will not modify this particular value. Okay, that is type 0. What exactly type 1 is saying? If client told you this fact number is a type 1 SCD, we will replace or we will override the existing value which means we will not maintain any history related to the fax number. Clear? Any doubts? So up to here we have discussed in the last class. Okay, let me go to the last slide. Users. Mhm. Okay, fine. Okay, the new one. I think CD not SQL. Okay. So let me go with this e-commerce Amazon. Okay. And then let me put here. So call LD product table with all the columns. Okay. Keep. Okay. You can see I have this table. It's not in public. It's in branch. So this example we already discussed, right?
Yes, we merged. Then we got the historical data
Yeah.
in the
Yes.
silver layer.
So yeah, so why? Because in the silver table we maintain the historical records. If it is a type 0, if I want to update some details, right? What I'm doing? So if it is a type 0, I will not update that particular column. If it is a type 1, I will override the particular column, but I will not maintain any history in the type 1. So when it comes to type 2, okay, in the type 2 we maintain the history. How we are maintaining the history? So while creating this table, okay, let me go here in the catalog. This one, schema, branch, LD products. 1 minute. Okay. Coming back. Yeah. So this is a staging table, LD products. Okay. So need match LD products. Okay. Match DWH products with these LD products. Okay. So this is in silver layer. Silver dot this, bronze dot this with all the columns from. Okay. So here you see, okay, here what I am doing. So whenever the existing data is coming, what I am doing, I'm updating the details. Now, for example, okay, this product name is SCD type 2, which means we will not change this value. What are the new value we are getting it right? We will not replace that particular value. That is type 0. What type 1 is saying? We are updating the historical record. Okay, what we are doing, we are overwriting the historical record. Okay, in type 1. Now, what type 2 is saying, So, in the type 2, we maintain the complete history. How we are maintaining the complete history? So, if you see here, okay, what we do if the same record came, okay, so there is already record called id1, so if the same record came into the table, what we are doing, we are updating the end date. Whatever the new record is coming, right, that we are inserting with the end date as a null, which means this particular id having price 300 from this date to this date, okay, and it has been updated as a 450 from this date. If it is end date is null, that means it's current current also, it is maintaining the same price. Okay, for example, take Amazon as an example. Okay, we have a product list, right? We have a product list. Okay, now every day, every week or every month, they will put some offers on iPhone. Okay, so for example, in Jan, so they have given 1100, okay, as 17, okay, $1100. Now in the Feb, they have reduced the price to 850. They have given some offer, okay, and on 17. So like that, every time the price is varying, right? I want to maintain complete history of that iPhone. So what I'll do, I'll put two columns here. One is start date, and then this is end date. Like that, we'll put two columns. So will in the start date when the price has been modified, okay, and in the end date I'll put as a null. Null means this is the active price, okay. So whenever the price varies changes, right, what we do, we'll update this end date and we'll insert a new record. So if we are maintaining like that, okay, so we'll have the complete history of the table, complete history of that particular product. Getting it right? Okay, so assume this is a company, so has which is in CA. Okay, from 2000 to 2004. In 2004, they have moved to the IL. Okay, so what we are doing, we are inserting the new record with a end date null. So this is what we do in the when it comes to script level, right? So what we do, so when matches, we'll update this price. When matches, we'll update this price. Okay, and what we are doing, we are updating this end date, its current timestamp. Getting it right? Select star from this. Okay. And let me put this. Okay. Let me truncate this table. Next, insert into this table. Select limit 1. Here I'm putting star, comma, current timestamp, comma, null. Why? I have two other columns, right? In the DWH table, I have in the last I have added two columns. One is start date, another one is end date. In the start date, I am putting current timestamp, end date, I am putting some null value, which means whatever the new records coming into the table, right, we will put it as a null. So let me insert this record. Done. I have one record in my table. Okay. Now what I am doing to implement SCD type 2, what we are doing, we are updating the price. Okay. Let me check the price in the this one in the silver table. So select this. Okay. Let me update this price. Update DWH product table. Set price equal to $100. Okay, done. Now you see here, okay, in the silver layer, okay, in the silver layer, whatever the data we have, in the silver layer, whatever the data we have, okay, I have removed it. In the silver layer, whatever the data I have, right? So it's a old price, okay, it's $100. Okay, now into the table, okay, I'm getting a new price from the bronze layer. Okay, whenever I'm inserting the data, what I need to do, so when I need to update the data, what I'm doing, I'm just putting end date as a current timestamp and I'm inserting the records. That's it. That's it. That's it. That's it. This is a SCD type 2 implementation. Nothing more. Clear? Any doubts? Again, I'm repeating. Okay. Assume this is Amazon data warehouse. Okay. In the Amazon data warehouse, I have three layers: bronze, silver, and then gold. Okay, whenever I'm loading the data from bronze to silver, what I need to do, I need to maintain the historical records, which means whenever these price changes, I need to have a complete history related to price. Okay, then what I do, I use SCD type 2 implementation. By implementing type 2, right, we'll have proper idea like when the price has been changed. Complete history will be maintained with the help of this SCD type 2. So in the type 0, we will not update any columns. In the type 1, we will override the existing value. In the type 2, what we are doing, we are not overriding any value. So we are updating this current record as a end date as a current timestamp. Previously, it's a null value. So if you see here, previously it's a null, which means it's a current price. Okay, current price is 100. Now what I'm doing, I'm updating this end date. Okay, by updating this end date, which means this 100 rupees is started at 2025 to 2026. Now what I'm doing, so the new price will be insert. We are inserting the new price here. Clear? Any doubts? So I have loaded 14 records by implementing SCD type 2. This is target. This is source. Correct only, right, when matching this. Okay. Now, if you check the table, if you see the table, so whatever the new records came, it has been inserted with end date as an see. This ID3 already having existing record. Okay. From 25 to 26, the price is 100 and the new price is 120 from this to this. Okay. If it is null, that means it's a current record. So like that, I can maintain complete history of this desk chair. Whenever the price changes happen, I'm maintaining the history with the help of the start and end date columns. Clear? Any doubts? Team,
No.
any doubts? Clear, right?
Yes.
And there is a type 3, type 4. We will not use it in the real time most. Okay, why? I'll tell you. In the type 3, what we do, we'll have only, we can maintain only limited history. We cannot maintain complete history. So here we have two columns, previous and current column. What we do, whenever we are getting the data, right? Okay, so whenever we are getting the data, let me go here. Same query, little bit change. Let me show you. So what I'm doing, here I'm maintaining the limited history, which means here only two columns will be there. Previous price, current price. Okay. Then what I'll do? So target dot price equal to. So what we are doing, I'm moving the target price into the current price into the previous price column. So here we'll have two columns. One is previous price and one is current price. Okay, previous price, current price. Okay, what I'll do, I will replace this current price into the previous price. Whatever the new price I'm getting it right, I will replace it in the current price. That is what will happen if I use this thing. Clear? Any doubts? So in the type 3, what I'll do, I'll replace this current price value into the previous price column. Okay. Now, whatever the data I'm getting it right, that I will insert here. Target price equal to, this is the source, right? Source dot price. That's it. So what I'm doing, if so the existing price will move to the in the existing price will move to the previous price column. Whatever the new data I'm getting it right, I will replace with replace into the current price. This is nothing but SED type 3. Here we can maintain only limited history, like previous price and the current price. We cannot maintain complete history. If I want to maintain complete history, I need to implement this SED type 2. Okay. And the last one is type 4. Type 4 SCD. Here we'll create another table and we will maintain all the historical data in another table. So this is type 4. And there is a concept called type 6. Here we merge type 1, sorry, type 2, type 3 and type 4 as well. So here we'll have previous address, current address, start date, end date, and there will be another table where we'll maintain the history. So in the real time, we use mostly type 2 implementation or type 4. That's it. So we'll not, 0, 1, anyway, we'll implement 0, 1, this 2, and then 4. So we'll, rare cases, we go with the type 3. I never use a type 3. I use it this 0, 1, 2, and then 4 in the real time scenarios. Clear? Any doubts? Anyone having any doubts related to SCD types?
Clears.
I'm creating one PostgreSQL. Why? Because this is the list. It's highlighted before. So to get to work with this what we called to work with the OLTP database, most of the companies will use this what we call this PGSQL only. Network policy, just create it. So I have created to this database back. Done. So I have this, it's creating still. Okay. So there is a concept called acid properties. Okay. So most of the databases will have the acid properties. What is acid properties? What is the use of this acid property? Okay, I'll tell you. Coming to here, it's creating. Still creating. It takes some time. Okay. What I'll do after this is created, I'll explain this acid properties. Okay. So there is a concept called cap theorem. Okay. That is also we required this trans. You have some idea about this thing. This is the last. Okay. Let me go with the data modeling. Okay. After this Postgres is created, I'll explain this cap theorem and acid properties. Okay. So coming back to data modeling, where we do the data modeling. Okay. We do data modeling in this gold layer. Okay. Where we are doing this data modeling, we are doing the data modeling in this gold layer. So what exactly mean by data modeling? Okay. So what exactly we do in this gold layer? Okay. We the BA developers will generate the reports. Okay. The BA developers will generate the reports. To generate the reports, okay, we need to have a proper understanding about the tables. Like we need a ER diagrams so that it's easy to understand. Okay, this is the column where we are joining with this table. This is the reference column. These are the values that we have in the gold layer. So data modeling is the process of creating visual or logical representation of data structures, relationships, and rules within a systems. It helps ensure clarity, consistency, and scalability how data is handled and across the multiple applications. Okay, so for the goal layer, whatever the tables we are doing, right, that should have these ER diagrams. Okay, with the help of these ER diagrams, this BA guy can understand the tables and he can create a reports by joining those tables. Okay, data modeling is the process of taking this raw data and then organize it and structure it in a meaningful way. So we are getting a raw data, we are storing it, and we are processing it in a meaningful way. That we call it as data modeling. Okay, so in the data modeling, we have three types. Nothing but we can design these ER diagrams in three ways. One is conceptual, logical, and then physical. Okay, so conceptual means big picture where we can show you how what are the relations with having with the tables. Okay, so this customer having relation with order, this product having relation with order, like that. We can create a conceptual model. When it comes to logical model, here we'll highlight at on what column they have joined these tables. Okay, in the physical model, they will highlight the data types, constraints, and everything. So this we call it as a physical data model. Okay, in the real time, based on the requirements, they will join this table. Now coming back, okay, in the data modeling, we will rename the table. We will rename all the tables into two categories. One is fact, another one is dimension. So whenever we are creating the tables in the fact and dimensions, right, we will start with see. If you see here in the SCD type 2, what I have mentioned, DWH, which means data warehouse, where we will maintain the data warehouse complete history in the silver layer. Here I have maintained LD. Okay, some tables will start with STG, which means it's a staging table or load table, where the staging and load tables will be in the bronze layer. Now, whenever I'm creating the tables in the gold, right, it will start with either fact prod, fact sales, or dimension product. So like that, the table names will start. What exactly this fact table, what exactly this, yeah, it's active. Fine, let me complete this fact and dimension data modeling and I'll come back to this acid properties. Okay, what is this fact and what is this dimension? Okay, whatever that data you are storing, right? Okay, it is the complete history related to particular item. Then we will name it as a dimension table. Okay, whatever the table having the values. Okay, it may be a price, it may be a quantity sold, anything. Okay, wherever there is a value, then we name it as a fact table. So product dimension table is all about description. Fact table is all about numbers. Okay, so while creating these tables in the what we call gold layer, when we are creating tables in the gold layer, we will name it as a fact and dimensions for better understanding. Now, okay, so this is fact table. And this is a dimension table. Dimension table will have the descriptions like country name, customer name, like that. Fact tables will have the values, sales, quantity sold, like that. Okay. So now if this fact table is depending on multiple type dimension table in the AR diagram, then we call it as a star schema. Again, this dimension table is depending on another dimension table, then we call it as a snowflake schema. It's not our snowflake, it's snowflake schema. What exactly mean by snowflake? If you take any iceberg, if you put some, if you pin it with some pencil or pen, it will form flakes, right? That is the reason. So this ER diagram look like say flakes, snowflakes. So that is the reason this ER diagram rename it as snowflake schema. Yeah. Okay. So simple and easy to understand, simple fact table dimension, fewer joins, better understanding, slight more storage, dashboards, BI tables, complex enterprise data, reduced storage usage, more joins, simple performance, split into subdimensions. Yeah. Any doubts? Okay. These tables having relations like one to one, one to many, many to many. One to one means this single record having single relation with this second table, then it is called one to one. If this table having multiple relation with this patient table, then it's called one to many. Here one record having multiple records with this many records, and here one record having multiple relation with this table, then we call it as many to many relations. In the ER diagrams, you can see like arrows and slashes. Arrow means one, line means one, many to one, like that. Clear? Any doubts? Okay, let me come to acid properties. Let me go to Postgres.
So why are we using Postgres here?
The OLTP. OLTP, I told you, right? We'll
Oh,
have
yeah. Sorry.
for the OLTP person, but so for this one, I need to have a tool, but I'm using Office laptop. Tomorrow I'll show you this. Okay. So what exactly, let me put in suspend mode with anything is fine, but in suspend mode, nothing will run. Okay. I'm suspending this. Tomorrow I'll show you what I want to show you. Okay. What exactly mean by, 1 minute. Okay. So database will have acid properties. Okay, this acid property is completely depending on this what we call session. Okay, in the Snowflake we don't have a thing called session, but in the traditional databases having this session concept. What exactly mean by session? Okay, so assume there is a user executing DDL commands. All the DDL commands are auto commit, which means I told to create an object. The object will be created. I told to modify the object. The object will get modified. But whenever I'm executing DML commands. First, these DML commands will be stored in the session. Okay, and then if the transaction completed, okay, then what we call it will be impacted, I think, but committed in the database. If the transaction failed, all the values will get rolled back. Getting it right? Okay. So did I explain you about this temp table concept? No, right? Did I explain temp tables? Permanent transit and temp tables. Did I explain those
No,
concepts?
no, sir.
No, right?
No.
Okay. So let me create a temp table. I'll explain this temp table concept later. Okay. What is this temp table? Create temp table ID int. Okay. So I have created one temp table called T customer. Okay. Now let me execute this. Okay. Okay. Let me use this branch. Okay. Let me create. Okay, I have created this database. Okay, up to when this table will be exist. Up to when this table will be exist until the session will be there. Okay, until the session will be there. Okay, this customer table will be exist. Okay, let me refresh. Whenever I refresh, the session will get terminated or closed. Okay, now let me try to call this same table. Okay, it's not got ended. Let me do one thing. I'll open new session. Whenever I click on new tab, new session will be opened. Let me copy this thing. So e-commerce branch, right? E-commerce and then branch. Now you see the table will not be exist. Okay, why? What happened here? Okay, so this table is not storing in the database layer, it is storing in the session. Whenever I connect to a database, between me and the database, the one session has been created. What are the DML commands? Okay, what are the temporary tables I will create that will be stored in this session? Clear? Any doubts regarding session? You got it right. What is session? Session means a temporary area. When the session will be created, when our user connect to a database, the session will get created. Clear about session?
Clear.
Yeah. Coming back. Okay. So all the databases will have acid properties. What is this acid property? A means atomicity, which means and either the entire transaction succeed or the entire things get failed. Okay, in the Snowflake we don't have that option. Okay, what exactly mean by transaction? I'll show you. Let me create this same whatever I have created here. Let me show you the same. Okay, so let me create again. Okay, it's there in the session, right? Let me insert some values. Insert into this customer. Okay, one values. Okay, now, okay, so if I execute all these things, it will be considered as a single transaction. Okay, all these things will be considered as a single transaction. Let me put A here. Okay, now I'm using integer as a data type. I'm using integer as a data type. But here I'm trying to pass some string value. Now what will happen? It will throw the error. Let me put begin and then end here. Okay, so if I'm executing this, this is as a complete transaction. Now if I execute this thing, right? Okay, so what need to be happen? Okay, it's failed. Now let me check this table. Okay, here the records got inserted, but in the post list, the records will not get inserted. Why? Because, okay, what acid property is saying, what A means atomicity, which means, okay, whenever I'm doing the transaction, right, first all this transaction will be stored in this session, right? Whenever this transaction failed here, okay, what happening here? So all the values will be rolled back, which means these records will not insert into the database. Whenever the transaction complete, then only these records will be stored. Okay. Now I'll show you tomorrow. Again, I'll repeat this concept tomorrow, and then I'll show you in the PostgreSQL. Okay. So what exactly I want to say is, so whenever I'm executing this query, this entire transaction, okay, so these records will not get inserted. Why? Database will consider this entire transaction as a single unit. Okay, whenever I'm trying to insert the data, these records, even though the error is here, these above records will not get inserted. Why? These above records are storing in the session. Okay, once this entire transaction is completed, then only these records are going to insert into the table. Okay, but in the Snowflake, it consider each individual as one record. That is the problem. That is the reason you are able to see these four records are inserted. But in the Postgres, you cannot see these things. Okay, you will not see any record in the table. Why? It has failed here. Okay, that is the reason all these values are rolled back, which means deleted in the session itself. It will not impact it on the database. This will I'll show you tomorrow. So what acid properties is saying? A means atomicity. Either the entire transaction succeed or entire things failed. Next, we have a consistency. All database rules are enforced or the entire transaction is rolled back. So here I have given more meaningful definition. Even though multiple applications are updating a file, the state of data should appear uniform, which means Let me go here. Okay, here what is happening? So this is my table. Okay, I'm loading one file. I'm loading one file into the table. Now, to complete this loading the data into the table, it may take around 5 minutes. It may take around 5 minutes. Okay, assume this is having 1 lakh records. Okay, 1 lakh records, 5 minutes of time. Now, multiple users are accessing the same table. Now, each user is going to get the individual data. So this guy executed 1 minute, this guy 2 minutes, this guy 3 minutes, this guy 4 minutes. Even though this transaction taking 5 minutes, okay, 5 minutes means it is inserting 10,000 records, right? Now, even though the 10,000 records are inserting into the table to reflect the data to the user. Okay, so this guy executed 1 minute, even though he has executed in 1 minute, after 1 minute, the table is having 100 records. This guy will, after 1 minute also, he is going to see only 100 records. After 2 minutes also, he is able to see 100 records. After 3 minutes or 4 minutes also, he is going to see 100 records only. Whenever the transaction complete after 5 minutes, at the sixth minute, he can see the updated records. 1 lakh 100 records plus 100 records he can see. Getting it right? So what consistency is saying, even though multiple applications are updating a file, the state of data should appear uniform. Okay, which means this file is updating the data. Okay, it is inserting the data. That inserted data will not reflected to all the users. Why? Because this records will be stored in session. Once the transaction is completed, then only that records will get reflected in the database. So that is the reason everybody can see the consistent data. Okay, once the transaction completed, then they can see the updated details. Before that, all the users can see the same data. Clear? Next, we have isolation. Simultaneous operators should not conflict with each other. Okay. Whenever I execute query, right? Whenever this guy is inserting some record and this guy is inserting some record, this guy is inserting some record, this guy is inserting some record into the table, this queries will not conflict with each other. It will form a queue. So first, this user one query will get executed. Next, it will execute user two, user three, user four, like that. It will form a queue. These queries will not conflict with each other. That we call it as isolation. Durability. Committed changes should be permanent. Whenever I committed the data on a database, the details are permanent. It will not change. So these are the one of the important interview question. So explain acid properties. In the acid properties, A means atomicity, I means C means consistency, I means isolation, D means durability. Okay, so this is one of the important interview question. Okay, next we have a cap theorem. What is cap theorem? Cap theorem, C means consistency, we already discussed. A means availability, P means partition tolerance. Okay, so there is a theory called a cap theorem where no database cannot satisfy 100% cap theorem. No database cannot satisfy 100% cap theorem. So what is this cap theorem? It's consistency, partition tolerance, and availability. Okay, let me put Snowflake here. Okay, so what are the data I'm storing in the Snowflake, right? It is doing the partition. So this Snowflake is having partition tolerance. Next, what we have? We have consistency. Okay, in Snowflake, we have a strong consistency for query. Once data is committed, then only they can see the data. So whenever I committed the data, whenever these records are completed, transaction completed, whenever I committed this transaction, then only user can see that particular data. Next, third point, availability. Mostly yes. Okay. There is a chance, a few times it is going to get failed. So 99% Snowflake will not get failed. A rare and rare cases, Snowflake will get failed. Okay. So what is this availability means? See, whenever I execute the query, what it is doing, it is switch on in the warehouse. Assume this warehouse is down in the AWS. This EC2 machine is down. Now, to assign this task to some other VM, it takes some time, right? So then sometimes we have a chance of availability is missing. So Snowflake is leaning towards CP, which means consistency and partition tolerance. It cannot maintain availability. 99% it will satisfy cap theorem. 1% it will not satisfy this availability. Clear? Any doubts? Whatever the database available in the market, it will not satisfy cap theorem. So each databases will fail at some point. That is what cap theorem is saying. Clear? Any doubts?
No
That's
doubt.
it.
So this is also one of the important interview question we are getting in the recent times. Just to go with these theory questions. Okay, so today I have covered two important, not two, four important questions. So one is SCD implementation, acid properties, and then this cap theorem. And last one more important question is normalization. Okay, so we have a concept of normalization and denormalization. Before discussing about this normalization concept, so you need to understand a few terminologies related to database. What are the terminologies? Let me show you. Okay, so we'll start. So there is a concept called entity attributes. Okay, in the real-time scenario, customers will say create customer entity with the column ID, with the attributes ID, name, phone number, email. Okay, what is entity? Entity is a real-life object. It may be a table, it may be a view or anything. Okay, so that we call it as an entity. Okay, what is attribute? Attribute is the characteristics of entity. Okay, if customer is a entity, then column names are attributes. Next. So we have a concept called prime attributes and non-prime attributes. Okay, the ID columns, whatever the ID columns we have, that we call it as a prime attributes. The values that are depending on these prime attributes are called non-prime attributes. Okay, so there is a concept called data integrity. Okay, so imagine database contain customer information without normalization. If customer changes the age, we need to update in multiple places, which increase the risk of data. So what is data integrity? So rather than storing data in single table, we store data in multiple tables. Why? So if we store the data in multiple tables, it's we can reduce the anomaly concept. Okay, we'll discuss this thing in the next slides. Next, storage optimizations. Next, efficiency query. This theory part you can read it. Okay, and there is a concept called anomaly. What is anomaly? I'll show you. Just read this theory, complete theory. I have provided in the PPT. Okay, so what is insertion anomaly? Okay, so anomaly nothing but if you are storing multiple information in a single table, then we will get this anomaly problem. So what is insertion anomaly? So assume I'm storing this student details and department details in a single table. Now school want to add one new department. Okay, without students, if I add this one, right, it's hard to update or delete or insert the data into this table. So this we call it as insertion anomaly. Okay, so what is deletion anomaly? Okay, if I want to delete these team records, okay, if I execute select star delete from table name where head of the department equal to steam, so here we are not going to lose the department details. Here along with the department details, student details also going to get deleted. This we call it as deletion anomaly. What is this updation anomaly? If I want to update some record, right, if I execute that update command, so I need to process 10 or 20 rows. So this we call it as updation anomaly. So to reduce this anomaly, we use a concept called normalization. Normalization is a process of structuring the data in database to eliminate redundancy. So what is normalization? Normalization is very simple. We will store the data in multiple tables. Okay, what we do? We store the data in multiple tables. Nothing but so to reduce this anomaly, what I'll do? I'll put the student details in one table and department details in one table. That we call it as a normalization. Okay, normalization is a process of organizing data in a database to eliminate redundancy and improve data integrity. So this process involving dividing database table into two or more tables by defining relations between the table. Okay, so here what I'm doing, I'm dividing the table into two or more tables. Okay, so in the table here, what are the columns? In the table B, what are the columns? How we can decide? By using these techniques. By applying these techniques, you will get to know what are the columns we need to put in table A and what are the columns you need to put in table B. Okay. So if you are getting this question in the interview, tell them I have applied up to 3 NF. So this BCNF, 4 NF, 5 NF, you cannot explain it. It's a lengthy thing. Okay. So tell them up to 3 NF. Okay. Just by heart these definitions. That's it. Okay. So benefits of normalization, less storage space, quicker updates, less data consistency, clear data relations, easy to add data, flexible structure. Okay, so 1 NF, first normal form. What first normal form is saying? All the values in a table should be atomic. What is 2 NF is saying? It should satisfy 1 NF and eliminate partial dependency. These are definitions. Okay, you need to buy what? Okay, what 3 NF is saying? It should satisfy 2 NF, eliminate transitive dependency. So tell them up to here. That's it. Going further, so what is atomic value? In a cell, in a table, there is a cell, right? In the cell, all the values should be atomic. You cannot store multiple values in a cell. Okay, so to reduce this anomaly, what I'm doing, what I'll add one extra row or one extra column to store that particular value. Here I have added one extra row and I have placed the max value in one row, science value in one row. So this we call it as normalization. What I'm doing, so I'm removing, I'm eliminating non-atomic value by adding one extra column or one extra row to process to store the records. So this is called 1 NF. What 2 NF is saying, okay, first it should satisfy 1 NF, which means all the values in a table should be atomic. We cannot store multiple values in a single cell. Okay, so first one, what it is saying, it should satisfy 1 NF and eliminate partial dependency. What is partial dependency? Okay, if you see here, I have a table, student ID, subject name, marks, and teacher name. Okay, here these two columns are called candidate key, nothing but a primary key. Okay, all the non-key column values should be fully depending on these two columns. If it is partially depending, then we need to divide the table into two parts. If you take the subject name is depending on subject ID, not on the student ID. Marks is completely depending on student and subject ID. Teacher name is depending only on the subject ID, not on the student ID. So here what I'll do is I'll divide this table into two tables. In the table one, I'll put student ID, subject ID, marks in one table, subject ID, subject name, teacher name in another table. So like that, what I'm doing, I'm storing the data I'm dividing the table into multiple tables based on this 2 NF concept. Next, we have 3 NF. What is the 3 NF is saying? First, it should satisfy 2 NF. That means it should satisfy 1 NF, 2 NF. Then only I will apply this 3 NF concept. What is 3 NF? Okay, it should satisfy 2 NF, eliminate transitive dependency. What is transitive dependency? Assume there are multiple values. I have stored in a single table, nothing but student and teacher details. Okay, here student is depending on teacher is depending on department head. Okay, or department table, even though there is no relation within the student and department. Okay, if I'm storing all the values in a single table, so automatically transitive dependency is created between this C and A. Okay, so to eliminate that one, what I do, I will store AB in one table, BC in one table. Clear? Any doubts? So these are definitions you need to by heart. That's it. Clear? So these are the four important questions we have. One is acid property, cap theorem, acidity types, normalization. These are the four theory questions you will get in the interview.
Yes, sir.
If you have any doubts, you can ask me. These are all theory. Just go with this slide one by one. Okay, so that's it. So we have done with this data warehousing concept.
Sir, can you upload the recorded
Videos.
videos after
I
28th?
told to institute multiple times. First of all, I don't have the access for
Oh,
this recording. I told to pull him multiple times. Today also I'll ask him. I'll try to update this guy. I'll request this guy to update. Okay. So from tomorrow we are going to start this ETL concept. Okay. So ETL means you already got idea, right? So we'll connect with multiple sources and we'll extract and load the data into the table. Okay. So to do this ETL things, we can do it in the SQL itself. Okay. So for that one, we have we have this type of object. File format is an object, stage is an object. We have multiple objects to load the data. So in this class, in this session, I'm going to show how to load data from AWS to GCP. At the end, I'll try to, on Saturday or Friday, I'll try to show you on the Azure as well. Azure is not in the course, but if you want, I'll show you in the Azure as well. Okay.
okay. Thank you, sir.
Yeah. So we'll connect tomorrow. So we'll start tomorrow ETL. So in the meanwhile, try to register in the AWS account and get,
Yeah.
let me know if you got the free credits or not.
Yeah, I'll just do it right now.
Okay.
Thank you,
Okay.
sir.
Thank you. Thanks, sir.
Thank you.